Saxon Math for 6th grade. We're going to be doing lesson 57 today, scientific notation. Now we've done some scientific notation before. Remember, the purpose of scientific notation is so that we can easily write and compare very large numbers with lots of places and very small numbers with lots of decimal places. It makes it possible for astrophysicists who study planets to compare their distances with those of physicists who study very small atoms and very small pieces. We're going to be playing around with our numbers today. So these are different ways to play around with them. Let's start with a reminder of what scientific notation is. Scientific notation always looks the same way. It is one number in the ones place. It can have a decimal after it, but it can never have a place above it. So it could be 1, or it could be 1.5, or 1.86, but it would never be 11. It would never be 100. It is always one digit in the ones place, and then sometimes a decimal. Then it always has a time sign, and then 10 to an exponent. The 10 to the exponent tells you how many places you're going to move the decimal to find the number in standard notation. So let's review what that looks like. If I have 1 times 10 to the 6th, in standard notation, this is the scientific notation. In standard notation, that would be 1, and then I would be moving the decimal place 6 places. In essence, I'm adding on 6 zeros. 1, 2, 3, 4, 5, 6. I'm moving my decimal place 6 places. Adding on my 6 zeros. 1, 2, 3, comma. 1, 2, 3, comma. In standard notation, 1 times 10 to the 6th would be 1 million. Because it's a positive exponent, I know my number is going to get larger. So notice it is larger than 0. I'm sorry, larger than 1. Here, I have a negative exponent. It works much the same way. I'm going to start with my number. In this case, it's 1. Here's my decimal point. But this time it changes. I want to move it negative 6 places. Negative 6 means I'm going to end up with a decimal. Negative exponents are decimals. So instead of writing it here, let me move this over. And let's write it over here. Now, let's move my decimal negative 6 places. That means that I'm going to be moving it this direction. 1, 2, 3, 4, 5, 6. Add in your zeros. Notice I only had to add in 5 zeros to get to the decimal place because my first place that I moved was to move it around the 1. Now I have 0.0000001. One very large number, a million. One very small number. Both of them written in scientific notation and then in standard form. Let's play with our numbers a little bit. What if I have 2 exponents and they're divided by each other? 10 to the 6th divided by 10 to the 3rd. How would I find an answer? I want to make my life easy. Let's look at what these mean. I remember that an exponent means that I'm multiplying the number times itself that many times. So here I'm multiplying 10 times 10 times 10. I'm multiplying 10 by itself 6 times. Here I'm multiplying 10 by itself 3 times. Let's see what that looks like. 10, 6 times. Times 10, times 10, times 10, times 10, times 10. Do we do it? 1, 2, 3, 4, 5, 6. Yep. Divided by 10 to the 3rd. 10 times 10 times 10. 6 tens, 3 tens. This would work with other bases or other exponents. Now I want to simplify my problem. You know, I know if I'm multiplying by the same number on the top and the bottom, that I can cancel them out. Times 10 and times 10. I can do that again. I have more 10s. I can cancel out another 10 and another 10. And I can do that once again. I could cancel out this 10 and that 10. Now I'm left with just 1 on the bottom. When you cancel out everything on the bottom, you're not left with 0, you're always left with 1. And I have 10 times 10 times 10. That's 10 to the third divided by 1. Any number divided by 1 is that number. 10 to the third. 10 to the sixth divided by 10 to the third is 10 to the third. You know, 6 minus 3 is 3. I think when I divide by numbers that have the same base but different exponents, I can just subtract the exponents and get the right answer. Just a tip. Let's look at a few more ways that we can play with our numbers. 10 to the 0, 5 to the 0, 2 to the 0. This is a rule that you just have to remember. There's not an easy way to write it out, but it's a very simple rule. Any number to the 0 power equals 1. 10 to the 0 is 1. 5 to the 0 is 1. And 2 to the 0, as you've already guessed, is 1. Last ways to play with our numbers today. So we've talked about scientific notation, where we move our decimals. We've talked about being able to subtract our exponents if we have the same bases and we're dividing. And we've talked about numbers to the 0 power equaling 1. The last thing we need to talk about is a different way to write negative exponents. A negative exponent is the same as a fraction. It's because a negative exponent is a decimal, and our decimals we can convert to fractions. There's an easy way to do that. If you have a number with a negative exponent, that is equal to 1 over the number 3 to that exponent without the negative sign. So 3 to the negative 2 is the same as 1 over 3 squared. Let's look at this one. 10 to the negative 3. Try it on your paper first. Make it into a fraction. It should have 1 on the top. On the bottom, it should have the same base, 10 to the third. No negative. Let's simplify these. 1 over 3 squared. I know that's the same as 1 over 3 times 3. 3 squared is 3 times itself twice, which is 3 times 3. 1 over 3 times 3 is 1/9. Well, that's much easier. Let's do the same thing here. 10 to the negative 3 is the same as 1 over 10 to the third. 1 over 10 times itself 3 times. 10 times 10 times 10. Which is 1 divided by 10 times 10, which is 100, times 10 more is 1,000. So 10 to the negative third is 1 over 1,000. You'll need to use all of these rules today to help you to accomplish your work.